Hello guys, hope all are fine. In today's class, we'll discuss very important topic that is understanding regression and performance metrics. Okay, so in understanding regression, we'll cover polynomial regression and logistic regression and also cover very important topic that is multi-collinearity. Okay, so then we'll discuss performance metrics. Performance metrics such as first one is accuracy. Okay, second one is precision. Third one is recall, and fourth one is F1 score. Okay, so directly we'll discuss multicollinearity. So, what is multicollinearity? Multicollinearity in machine learning refers to the presence of highly correlated predictor variable which can lead to unstable model coefficient, inflated standard error, and difficult in interpreting future importance. Okay, so multicollinearity is used for in machine learning, it is used for feature selection. Which feature is important for training? Okay. To address multicollinearity techniques such as feature selection, feature transformation, and regularization, and collecting more diverse data can be used. So it is important to mitigate multicollinearity to improve model performance and interpretability. So here in multicollinearity, suppose you have three features that is F1, F2 and F3. Okay, so in three feature, suppose F1 and F2 are related to are related to 96%, that is 0.96. Okay, so these two features are related to 96%. So it is a duplicate feature. So one of the them is duplicate feature. So we reduce the duplicate feature in data set. Okay, so suppose example, we will give in example linear regression such as house price prediction. Okay, so in house price prediction, if two features are present, one is house size and another one is suppose number of rooms. Okay, so it is related to 0.95. So the price of the house depend upon the one of the feature that is house size or number of room. So two features are similar to each other. So here one feature is deleted. Okay. So it is the multi-collinearity. Okay. So in multi-collinearity, two important concept is there, that is overfitting and underfitting. Second one is underfitting. So in overfitting, when suppose training accuracy is suppose when overfitting is occur, when training accuracy is suppose training accuracy is 95%. Okay, but testing accuracy is 60%. So here low bias and high variance and high variance. Okay, low bias and high variance. So in this case, overfitting is occur when training accuracy is maximum and testing accuracy is minimum. In this case, it is overfitting. We'll call it is overfitting. So we'll discuss what is overfitting in later in one class because it is very important. So you have basic idea when training accuracy is maximum and testing accuracy is minimum. So we'll call this process was overfitting. So in underfitting, your suppose training accuracy is minimum and testing accuracy is minimum. Training accuracy is suppose 60% and testing accuracy is 55%. Okay, here training accuracy is minimum and testing accuracy is minimum. So it is called as underfitting. Okay, so here high bias and high variance and high variance. In overfitting that is low bias and high variance, but in underfitting that is high bias and high variance. So for normalize the model, you remember for normalize the model will require training accuracies for best output, training accuracy is maximum and testing accuracy is also maximum. Okay, so in this case that is low bias and low variance. Low variance. Okay, so normalize the model, training accuracy is maximum and testing accuracy is maximum. In this case, low bias and low variance. Okay, so you remember what is your overfitting, what is your underfitting, and what is the normalized the model and what is multi-collinear. So we discuss now that is polynomial regression. So in polynomial regression, you remember key characteristics that is allow for curved relationship between variable. Okay, allow for curved relationship between variable. We will discuss linear regression that is same as polynomial distribution. Slight differences extend the linear regression by including polynomial term. Okay, here some polynomial term is there. Mathematically, this is defined by y equal to suppose b0 b1x plus b2x2 plus b3x3 plus bnx1 plus epsilon. So here y is dependent variable. Okay, so independent variable is x. Okay, here b0 b1 up to bn coefficient to the estimate. Okay, and x1 to xn that is polynomial term. Okay, here x2 x3 that is polynomial term, x is independent variable and y are dependent variable. So in polynomial regression, if you notice the graph will like this, you know the graph in linear regression, but in polynomial regression the graph like this. Okay, you know if the point are like this. Okay, so in linear regression the line is like this. Okay, but in polynomial discuss regression, to reduce the error, the regression line will be like this. Okay, okay, here you notice the error will be minimum in polynomial regression. Okay, so this equation is h theta of x equal to theta 0 plus theta 1 x1. Okay, so if in polynomial regression you will assume, okay, suppose if polynomial regression degree is 0, suppose in polynomial regression, okay, suppose when degree equal to 0, degree equal to 0, this implies the equation is theta 0 into x1 to the power 0, that is theta 0 into 1, that is theta 0. When degree equal to 1, that is h theta of x, that is theta 0 into x1 to the power 0. plus theta 1 into x1 to the power 1, that is theta 0 plus theta 1 x1. Similarly, for degree equal to 2, it will become a theta of x, that is theta 0 into x1 to the power 0 plus theta 1 into x1 to the power 1. So like this, it will be become directly we will write the equation, that is theta 0 plus theta 1 x1 plus theta 2 x2 whole square. Okay, similarly for up to n, we will write suppose degree equal to 3. You will simply write equation of polynomial regression, that is theta 0 plus theta 1 x1 plus theta 2 x2 square plus theta 3 x3 cube. Okay, so like this. Suppose example, we'll write a example, that is suppose example features are, we'll give three feature, that is x1 and x2 and x3. So here the polynomial degree is 2. Polynomial degree is 2. Okay. So in polynomial degree 2, so h theta of x equal to theta 0 plus theta 1 x1 plus theta 2 x2 plus theta 3 x3 plus theta 4 x1 square plus theta 5 x2 square plus theta 6 x3 square. Okay. So it is the example of polynomial degree 2 for three features. Okay, for x1 and x2 and x3. Okay, so we'll discuss now, that is logistic regression. Okay, so it is not a regression algorithm. Many times it is confused because many times students assume that it is a regression algorithm, but actually it is not a regression algorithm, it is a classification model in ML. Okay, so it is a binary classification. Okay, so here predicting binary outcome, that is binary outcome 0 1 or true false or yes no or spam or not spam, like this. So key characteristics of logistic regression is sigmoid function for probabilistic estimation. So we will teach one of the function that is very important in deep learning, that is sigmoid function, and decision boundary for classification. Okay, so here first we will assume a data set. Okay, suppose data set is number of study hour and pass or fail. You are pass or fail. It is a binary classification. Suppose you study 1 hour, then you must fail. Okay, if two, if then fail, then three, then fail, then four, also fail, on five, pass, six, pass, seven, pass, nine, fail. Okay, suppose it is a data set. If you draw the regression line, okay, if you draw the regression line, so line will be like this. So it is your study hour, okay, it is your study hour, and if fail that is 0, if pass that is 1. So you draw, first one is if study hour is 1, then it is fail. Suppose it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if study hour is 1, that is fail. So the point will be like this. Okay, if study hour is 2, that is fail. So point like this, 3 fail, 4 fail, 5 pass. Okay, then 6 pass 7, pass 8, pass and 9, that is fail. So the line will be like this. So but actually regression line will be like this. Okay. So for some outlier present, the line will be also change like this. If some outlier is present, okay, like this, line will be changes like this. So it is the regression line. So here error will be maximum. Error will be maximum. Okay. So here, so if you have doubt why we cannot use linear regression, linear regression for classification, for classification. Okay. First one is that is best fit line. For best fit line changes because presence of outlier. Okay. So second one is the outcome comes greater than 1 and less than 0. Okay, to solve this problem, we'll use logistic regression. Logistic regression. Okay, so here we'll assume the output will be in the 0 1 form. Output will be 0 1 form. That is the squashing technique. Okay, that is the squashing technique. So how logistic regression solve classification model? Now I will see how logistic regression solve classification problem. Okay, so you know that is previous line will be like this, will not row again and again. Okay, that is some point is present here and some point is present here. Okay, so here you notice logistic line regression line in the output that is only 0 and 1, that is pass or fail is present. Pass or fail is present. So we will see the output in 0 and 1. If it is pass, then output is 1. If it is fail, and output is 0. So we will assume a function that is sigmoid function. Sigmoid function. And by using sigmoid function, we solve this problem with 0 to 1. That is 0 and 1 form. Okay, so now see how. So the sigmoid function. So sigmoid function is 1 by 1 plus e to the power minus z. Okay, so here z equal to a theta of x, that is theta 0 plus theta 1 x1. Okay, it is your best fit line. It is your best fit line. Okay, so if you apply on this best fit line sigmoid function, then it convert it to 0 to 1. Okay, then it convert to 0 to 1. So in s theta of x, you will use sigmoid function, that is theta 0 plus theta 1 x1, that is s theta of x equal to 1 by 1 plus e to the power minus z, that is minus theta 0 plus theta 1 x1. Okay, if you apply this sigmoid function, then output will be 0 to 1. Okay, not a minimum to 0, not maximum to 1. Okay, so if you notice what is the difference between, okay, difference between linear regression cost function and logistic regression cost function. Okay, so here you notice j theta 0 theta 1, that is our equation in linear regression, that is 1 by n summation I equal to n yi actual minus predicate whole square. Okay, so in here j theta 0 theta 1, that is same 1 by n summation I equal to 1 to n and yi minus s theta of x whole square. Okay, so only difference is here a theta of x equal to theta 0 plus theta 1 x1. But in here a theta of x equal to 1 by 1 plus e to the power, that is minus theta 0 plus theta 1 x1. Okay, it is the difference between logistic regression cost function and linear regression cost function. So now we will discuss what is difference between classification based regression. So before classification versus regression matrix, we will see some practical application of polynomial regression and also logistic regression. So suppose example of real world application of polynomial regression are predicting stock price based on the historical data. Okay, suppose you predict the stock price. Example is polynomial regression, mm, stock price. Okay, stock price prediction. Okay, and second one is modeling population growth in biological science. Okay, so modeling population growth, and also in third, that is analyzing customer behavior in marketing research. Analyzing customer behavior in marketing. Okay, these are the some application. And similarly, real world application for logistic regression are, suppose first one, prediction customer prediction. Okay, in business analysis. And second one is disease diagnosis in healthcare. Okay, so these are two real world application of logistic regression. So okay, now we'll discuss what is the difference between classification and regression. So purpose of performance metrics: measuring model quality, comparing model, guiding model environment improvement. Okay, so measuring model quality, for model quality also, and comparing the model and guiding model improvement. We'll use metrics. Okay, Example of classification matrix are, okay, classification matrix are that is accuracy, precision, recall and F1 score. We'll discuss in today's class, that is classification matrix, that is accuracy and precision and recall and F1 score. Okay, and example of regression matrix we'll discuss in last class, that is mean square error, root mean square error, and mean absolute error, and R square. Okay, so we'll discuss in last class. Now we'll discuss what is classification matrix, that is accuracy, precision, recall, and F1 score. So first we'll start accuracy. Okay, then precision, then recall, then F1 score. Okay. So here accuracy. Accuracy is one of the fundamental metrics used to evaluate the performance of classification model in machine learning. Okay, it measures the proportion of correct prediction made by the model out of all prediction. Okay, suppose you notice it measures the proportion of correct prediction made by the model out of all prediction. Okay, it is very important. Okay, if suppose your model is present many example. Suppose I will give a example, that is x1, x2, some features x1, x2 and some actual, okay, and predicted. Okay, it is your actual output and it is your predicted. Okay, suppose some features is there. Okay, some features is there. Okay, so here the actual output is 0, okay, and 1 and 0 and 1 and 1, 0 and 1. But predicted value is here 1, here 1 and here 0, here also 1, here also 1. Okay, so you assume it is 0, then 1, 1, okay, then 1, then 0. Okay, suppose here your actual output is 0 for first feature, but we'll predict it is 1, and for second it is 1 and our output is also 1. So we'll calculate what is the accuracy, what is the percentage of accurate value, okay, of our prediction, of our model. Okay, so here there is important concept, that is confusion matrix. It is very confusion also. Okay, so confusion matrix. Okay, so okay, so it is 1 and 0, and it is also 1 and 0. 1 means true, 0 means false. Okay, so it is actual is 1 and predictor is 1. So here you notice 1 1. Suppose 1 is 1. How many 1 1 present? That is, you notice here 1, then 1 1 2, then 1 1 3. So here you write 3 because your actual is 3, actual is 1 and predictor is 1. Okay, but in here you write 1 0. So here 1 0. So for 1 0, that is 1, and any 1 0 is present? No. So it is present 1. Okay. And for 0 1. Okay. For 0 1, here 1 present and here 1 present. Okay. 2. 0 1 and 0. Okay. Okay, so here you notice on for 0 1 0 0, sorry, 0 0, that is 1 is present. We'll divide this as assume 0 0. Okay, so it is 1. Okay, so in confusion matrix, if you draw this matrix again, so it is like this. Okay, so here your 1 and 0, and here that is 1 and 0. So it is your true positive and false positive and false negative and true negative. Because 1 1, our actual is 1 and predictor is 1. So it is true positive. Okay, if your actual is 1 but will predict 0, so it is false positive. If actual is 0, that is false, but we predict 1, that is false negative. So if 0 0, our actual is false and predicted false, so it is true negative. Okay, so you remember like this. Okay, so your accuracy. So first one is accuracy. So how to find the accuracy? Accuracy, the formula of accuracy is true positive plus true negative whole divided by total. Total means true positive plus false positive, true negative plus false negative. It is very very important formula. Okay, for accuracy. Okay, if you calculate here accuracy, that is 3 plus 1. 3 is true positive and true negative is 1. So 3 plus 1 whole divided by total, that is 3 plus 1 plus 1 plus 1. That is 4 by 7. Okay. So suppose in a data set is present. Okay. In data set, that is 1900, output is 1. Okay. And for 100, the output is 0. Okay. Here you notice it is imbalanced data set. Okay. Imbalanced data set. Here you notice the data model is accuracy. Data model accuracy is 90% because it is 900 time our output is same as the actual value, and 100 time our actual value and predicted value are different. So its data model accuracy is 90%. Okay, so accuracy is a simple yet essential metrics for evaluating classification model. Okay, so understanding its strength and limitation is crucial for meaningful model evaluation. Okay, so we directly discuss precision and recall after accuracy. Like this, if you draw the same matrix again, okay, that is our true positive, true negative, plus false positive and false negative. That is 1 0 and 1 0. Okay, so in accuracy, the formula is 2 positive plus 2 negative whole divided by total. That is 2 positive plus 2 negative plus false positive and false negative. Okay, but in precision, the formula is true positive by true positive plus false positive. For recall, The formula is true positive will divided by true positive plus false negative because it is out of all actual value how many are correctly predicted. It will calculate out of all actual value how many are correctly predicted. So here false positive is important. False positive is okay important. S- Okay, and here false negative is important in recall. Important. Okay, so we'll discuss precision and recall with a real life example. Okay, with a wonderful real life example that is for male example. So the male spam classification. Okay, suppose we give a example that is spam classification. Spam classification. So we'll notice here the male is spam or not spam. Okay, suppose one male is given and it is spam, that is truth. So male spam. Okay, so it is good scenario. Good scenario. Sometimes you notice your mail is not spam, but it goes to the spam folder. So if mail not spam, but is go to the spam folder. Okay, so it is false positive. So here we reduce the false negative. So here you can use the precision. So it is the example of precision. Okay, after that we will notice direct one of the important performance matrix that is F1 score. Okay, in F1 score is the harmonic mean of precision and recall, providing a balanced measure of model performance. Okay, so in F1 score, it is the harmonic mean of precision and recall. Okay, so the F1 score formula is 2 into precision, sorry, the formula is precision into recall plus 2 into precision plus recall. Okay, so it is the harmonic mean of precision and recall. Okay, suppose we give a example that is real life example. Predict whether a person has diabetes or not. In this case, you notice if you apply the recall, it is good because we reduce the false negative. Okay, in this case, we reduce the false negative because diabetes of a person is very, very important. In this case, if we increase the false negative, it is very difficult. Okay, for the output. So here, if you give an another example that is tumor, stock market is going to crash. Okay, so here use F1 score because here false negative is important and false positive is important. In this case, you will use F1 score. Okay, so it is the real life example. In precision, measures the proportion of true positive prediction out of all positive prediction made by model. But in recall, we will focus on false negative. Okay, so it is the real life example of F1 score. In today's class, we will discuss some performance metrics, that is precision and recall and accuracy, and also one important that is F1 score, and also polynomial regression and regression, logistic regression with sigmoid function. Okay, in next class we'll discuss direct supervised learning, very important model that is decision tree. Okay, so thank you.